takes you to parts of the building that are not public. Okay? All right. Here's our telescope. I hope you like it. I want to talk about how this one works, and to do that, I have a model. See how my model looks just like the telescope? It's a beige tube. Right. At the bottom of the telescope tube, just over my head, is the primary mirror. And the primary mirror in this telescope is 107 inches in diameter. That's why we call this the 107-inch telescope. It's 12.5 inches thick. There's a hole in the middle of the glass, 30 inches across. And the glass of the mirror weighs 7,800 pounds. That's why I really like having a model. It's so much easier to do this with a model than with a real telescope. The mirror in the model is different from the mirror in the telescope in a couple of important ways. One of them being, this one is covered with my fingerprints. The one in the telescope has absolutely 0 of my fingerprints on it. Maybe more important than that, this one's flat. Let's put a telescope together with a flat mirror. Most of the tube is hollow, okay? Put the telescope together with a flat mirror and point it at space, and starlight comes in from space and hits that flat mirror. Where's that light gonna go? Right back out into space. That's not useful. What we want to do is collect the light. So our telescope mirror has a very slight concave curve. When the starlight reflects all of that, it reflects upward in a cone shape toward a focus. So all the light gets gathered together just past the end of the telescope tube. Actually, out the end, between the end of the telescope and the wall. Well, that is not a convenient place to go to study starlight. So with our telescope, just before the light reaches a focus, we capture it at the top with mirror number 2, the secondary mirror. And that secondary mirror is smaller because the light's all kind of gathered together there, and it redirects the light back down the telescope tube. Back down the telescope tube. Now we have to decide what we're going to do with that light. We can send the light through the hole in the primary mirror. And we can attach an instrument of some sort right at the back end of the telescope. What we see back here is that this port is covered with something that looks a little like a trash can lid. So we're not using that port. Until yesterday, the instrument that is under the tarp up here, upper left, was attached back there, and that is a spectrograph, just like what we do at the Hobby Everly telescope. And it was attached there, and that was the instrument astronomers were using. But new astronomers are here now. They want a different instrument, and so it's not this spectrograph. So the team had to reconfigure the telescope yesterday and make it usable for the next astronomers. Where are they sending the light? Well, those of you on this side of the room might notice that there's another port on the side of the telescope tube, just over my head. Looks like it's covered with a trash can lid. I'm sure I'm not supposed to call these trash can lids because they are highly technical mirror telescope covers, but we don't have anything attached there either. And what we'd like to attach there is the instrument that's under the white tarp that's over here to my right. And would be attached right here. But let me just ask you, if we attach an instrument to the side of the telescope, starlight comes in from space and strikes the primary mirror, goes up to the secondary mirror. Now the telescope tube, how would you make the light turn the corner and come out the side? I always like it when people answer with their hands. That's how you do this. Yeah, so there's a mirror number 3 is right in the middle of the telescope tube. And when we deploy it, we move it to a diagonal position. And as the light's coming from the secondary mirror, it hits that mirror number 3, and that gets redirected out the side of the telescope. And mirror number 3 can be rotated to send the light out the bottom, or the side, or the top. Or mirror number 3's 4th position, where the light gets sent out the back of the telescope tube to this point over my head. Anybody want to guess what's in there? Hope you're guessing a mirror. Mirror number 4 is in there. Mirror number 4 is another diagonal. It redirects the light down this big pipe, and the light goes all the way downstairs and into the instrument that takes up most of the floor below us. So you are standing on top of a very large spectrograph. keep saying spectrograph. So what that's doing is it takes the starlight, spreads it extremely widely into its spectrum. This is one of the highest resolution instruments on a telescope in the world. And then camera technology captures that spread out light, sends the information to the astronomer's computer. The astronomer sits behind the door to your left, looking at the computer. The astronomer does not sit downstairs looking at rainbows or up here looking at the telescope. They're back in there in the control room where it's warmer, and they're looking at the computer. Just like regular people in their jobs. Alright, so that's where the light's going for tonight's astronomers. And what you can tell is that this telescope has a lot of different ways it can be configured.